Alright guys, SAT time! Okay, so for SAT set 12, for what value of c will the equation give an integer solution? So this was a quadratic, so I subtracted the c over to make it equal to 0. And I wasn't really quite sure how to factor that since I didn't know it, but part of the quadratic formula, the b squared minus 4ac part, that discriminant, will kind of tell me what types and how many solutions I have. So I used that and I did b squared, which would be 1, minus 4 times a, which is 2 times negative c, so yeah, like, I don't know, negative c, whatever. So I got 1, and then the double negative is going to make it a plus 8c, and all of this is under a root. And so if I want an integer solution, I need for this to equal a perfect square number so that when I square root it, I can get a nice integer answer. And so I considered each of these numbers here and which one of those would give me a perfect square answer if I plug it in, multiply by 8, and then add 1 to it. So hopefully that's enough to get you there. For this next one, we just have to solve for x. Now the fractions can be a little overwhelming. In Algebra 2, we're about to get to this where we solve the fractions, but I just took a look at all my denominators. I multiplied by the greatest common denominator or least common multiple to get rid of all those, which would be 6. And then I multiplied it to each number so that I didn't have to deal with fractions anymore. So 2/3 times 6, like the 3 and the 6 will cancel out to 2, so 4x. Negative 4 times 6 is negative 24. The 2 and the 6 will cancel to a 3, so you'll have 3x plus 3, because you need to multiply the 3 by that whole numerator. And then minus 6, because 6 times 1 is 6. And then that should hopefully be a super easy problem to solve after that. So just a sneaky way to make your math faster. Okay, our location problem. If g of x is the reflection of this line, first across the y, then across the x, what is the value of g of 3? So I tried doing this with the line, but I think it's just easier to plug in the 3. So if I input 3, your x value is 3, your output is negative 15. Then if I take that and I put it across, or I take it and I put it through a reflection across the y-axis, then I change x. And if I then flip it across the x-axis, I change y. And what is the value of that? Well, if this was my input, then my output is the one that I want. So 15 is the one I want. Oops, answers. Okay, set 13. We have f of x is this, p of x is that. What is the value of p of 6? So I just put the 6 in place of all these x's here. So if I have p of 6 equals f of 6 plus 2, then really I'm plugging in 8. And hopefully you can just finish it after that. Now this fraction problem, unlike the one I just did on the back, is a little different. Because it's just one fraction equal to one more fraction, I'm just going to cross multiply. And specifically, they want the y-intercept of this curve. I don't even really need to know that it's a curve. A y-intercept always happens when x is 0. So I can just replace x with 0. And so really I'm looking at 3 over 2 equals 6 over y. And then I just cross multiplied to solve. Okay? This is something that we are doing right now in year long and that we've already done in Algebra 2. The equation could have at most 3 real solutions. Adding all the solutions together for this equation gives what value? So I took this 4-term polynomial and factored it by putting it in the box. And so I had x to the third, negative 7x squared, 4x minus 28. I factored that. So we get x minus 7. And I feel like I forgot a negative somewhere, no? X squared plus 4. Adding all the solutions together for this equation gives what answer? Well, I can see one of my solutions right now is 7, and then I'd have to set this equal to 0 to get the other one. And then I think you should know your answer because we're talking about real solutions only. Okay, moving on. Set 14. Algebra 2, this is actually something that we have already done and we will do soon in year long. So they want me to divide these two, and because I'm dividing by a linear factor, I can do synthetic division. So I put the -2, opposite, outside the house. I wasn't missing any exponents, so I just 2, 5, -7, 5. Synthetically divide by dropping that down, multiply, then add, continue the process. That last number is your remainder. Okay, set 14, occupation. Given that f of x is this and g of x is that, and h of x is when I compose the two, find the constant. So they're telling me to put this into g, so they want f to go into g. So I'm going to take 2x minus 1 and square it, and then add 1. When I square things like that, remember we have to write it twice, and then FOIL. And then we're looking for the constant value, which is the one without x. So after I've FOILed and combined like terms, the one that doesn't have an x on it is the one you want. All right, and location. This is something that we just finished up in Algebra 2. So I wanted to solve for x here, and they told me what y was. So the first thing I actually did was I sneaky rewrote that 27 as a 3 to the third, smashed up against y, which I really know is 5 over 3. And since my bases are now the same, I can just ignore them and do 2x plus 1, the exponent, is equal to that 3 times 5 over 3. And this will allow me to solve for x. And since I already know y, I'm going to do 9 times 5 over 3 plus 4 times whatever I get for x, which may or may not be a fraction, I don't know. And then whatever you get is your location. So hopefully that's good there. On the back, problem set 15. Just rocking through this. If f of x is the graph on the right, what is the smallest value of c such that the graph f of x plus c has exactly 2 real roots? So right now it has 3 real roots because it's touching 3 times, and it's wanting me to essentially move it up. I could move it up or down, but because of the plus and because these are positive answers, how much do I need to shift it up so that this graph will only touch the x-axis 2 times? So I feel like I just need to get this up there 1, 2, 3, or 4 amounts so that it's still touching once over here and once over there. So you have a total of 2 touches. Okay, our occupation problem, if c is 3 root 6 and 3 over 5c is square root of x, find the value of x. So I plugged in c. And then to solve for x, I realized I was going to have to square both sides to get x alone. Now here I really have 9 root 6 over 5, and when I square that, I have to square all the things in there. So it's going to be like 81 times the square root of 6 squared is just 6 over 5, and they want me to find that and round it to the nearest integer to pick the correct answer. And then last but not least, the expression 2x squared minus 13x plus 20 factors like that. What is the average of a, b, c, and d? So average is when you add them all up and divide by how many you have. So you're definitely going to divide this by 4. You just have to get that sum. So to factor this, if you have 3 terms, and we just did this in year long, and we've done this already many times in Algebra 2, I'm thinking what multiplies to 40 and adds to negative 13? And then whatever I get, we want to remember that we have to divide by 2. And if we can't divide, we got to remember to bottoms up. And so whichever values I get here, 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 and here, just the numbers, not the x's, We're going to add up A, B, C, and D, and then divide that all by 4 to get our average. All right, that's super quick. Good luck.